Hello friends, welcome back. In today's video, we will go through a set of questions which will help in the preparation of the interview on an AWS Administrator role. So now to understand what is the role of an AWS Administrator. So AWS, as we know, is Amazon Web Services, which is a cloud platform or which provides cloud services to host infrastructure applications and so on. An AWS administrator plays a pivotal role in ensuring the smooth operation, security, and cost effectiveness of an organization's cloud infrastructure hosted on AWS. This role requires a blend of technical expertise, strategic planning, and the ability to adapt to the rapidly evolving cloud technology landscape. Now, what kind of questions we can expect from an interviewer? So we have broke them into four categories basically. Starting, it will start from its basic set of technical questions, and as we go on, the complexity of technical questions would increase, and which falls under the advanced technical questions. Then there could be few scenario-based questions, and at last there would be few behavioral questions. Now, let's go through few of the technical questions which we can expect. What are the key services provided by AWS? The response could be AWS provides a wide range of services, including but not limited to compute services, which is equal to our virtual instances or virtual machines on which we install Windows or Linux or any flavor of OS. Is called compute. So it's nothing but a virtual machine hosted on cloud. So compute service, in compute service we get EC2, elastic compute, and then Lambda. Under storage services, there are three of them: S3, simple storage service; EBS, elastic block store; and then Glacier. Under database, we have database services. The first one is RDS, relational database service, and then DynamoDB, and the next one is Redshift. Under networking, there are networking services: VPC, Virtual Private Cloud; Route 53, CloudFront. Management tools, AWS provides following management tools: CloudWatch, CloudTrail, AWS Config. Moving on to the next question. Explain the difference between Amazon S3, EBS, and EFS. So these are storage services, and we'll see what are the difference between all these three types of storage services provided by AWS. Amazon S3, simple storage service, an object storage service used for storing and retrieving any amount of data from anywhere on the web. EBS, elastic block store, block storage for use with Amazon EC2 instance, designed for workloads requiring frequent updates. EFS, elastic file system, a file storage service for use with AWS cloud services and on-premises resources, offering scalable and elastic file storage. The next question: how do you secure data in transit and at rest in AWS? Data in transit means when the data is moving from one place to another place, from a source A to source B, is called data in transit. So how we can secure it? Use TLS, transport layer security, for encryption. Services like AWS Certificate Manager can help manage SSL and TLS certificates. Data at rest, which means data is sitting somewhere, which is like it is stored on a storage, or it is sitting, it's not moving, it's being stored on a place, it's just sitting there. Use encryption features like AWS Key Management Service, KMS, to manage encryption key and enable server-side encryption for S3, EBS, and RDS, which are the storage services provided by AWS. Jumping to the next one, what is an IAM role and how is it different from an IAM user? So we have IAM user and IAM role. Now, what is IAM user? An entity that represents a person or a service interacting with AWS. Users have permanent credentials and are used for day-to-day interactions with AWS. Now, what is IAM role? It is a set of permissions that defines what actions are allowed and defined by an identity in the AWS account. Roles are assumed by trusted entities and they provide temporary security credentials. The next one. What is the difference between vertical scaling and horizontal scaling in AWS? As we know, cloud give a feature of scaling the application, scaling the resources based on the use. So in AWS, we have two kind of scaling. One is vertical scaling and one is horizontal scaling. Let's see what they are. Vertical scaling, increasing the instance size, example from T2.micro to M5.large to increase capacity, right? Which you can take and understand with an example. You have a virtual machine which is running with 4 CPU as an example, and 8 gig of RAM, and you want to increase the performance by increasing the CPU or memory and so on. So this is called as a vertical scaling. Now what is horizontal scaling? Increasing the number of instances, example adding more EC2 instance to distribute the load. So horizontal scaling is in scaling the number of instance or number of virtual machines to fulfill the user load or to fulfill the demand of more resources for the same application. So instead of bumping up the same server, what we can do, we can uh, provision more in similar instances which will distribute the load. So if there is a request coming for an application or from the end user, instead of hitting to one server, we can break them into 5 instances or scale it vertically, so that the number of hits or number of user requests coming to one server will be distributed to the 5 servers. So the processing would be faster. The load on one particular server will reduce and it will able to respond faster to the end user. So if you want to increase the size of the same server, it's called as vertical scaling. And if you want to increase the number of instances which for a particular application or service, it called as horizontal scaling. Next one. Explain how you can connect to an EC2 instance using SSH. Response. Obtain the private key .pem associated with the EC2 instance. Ensure the key has appropriate permissions, which is chmod 400 keyfile.pm. Use the SSH command ssh-i path _to _keyfile.pm ec2-user@instance_public_DNS. This will help in connecting to an EC2 instance using SSH. Now the next one is, what is an auto scaling group and how does it work? An auto scaling group, ASG, is a collection of EC2 instances managed by the auto scaling services. It allows automatic scaling of the number of instances based on the defined policies, health checks, and the schedule to ensure the application maintain performance and availability. So it is again a kind of a horizontal scaling, wherein we provision more EC2 instance or decrease the number of EC2 instance based on the usage or based on the schedule. And This can be done on various triggers, like we can say that we can set up policies that number of EC2 instance auto provision during the business hours, say morning 8 to evening 6. We will have more number of EC2 instance, and after 6 we will have lesser number of EC2 instance. So it could be automated, and we can set those policies using auto scaling groups, right? Or we can have a health check policies, like if a CPU goes more than 80%, provision a new EC2 instance. So that way we can auto set, and the ASG will take care of it based on the policies we have defined. The next one would be, how does Route 53 provides high availability and low latency? High availability, Route 53 uses, sorry, Route 53 uses multiple DNS servers globally to ensure redundancy and fault tolerance. So that way it provides high availability. It has multiple DNS records scattered across the globe, and hence provide availability. Low latency, it uses a global network of DNS servers to route users' requests to the closest DNS servers, reducing latency. So everywhere there would be a DNS server available, and it would be able to process the request faster because of the availability of the DNS record across. Now we'll go to the advanced technical questions, wherein the complexity of the questions would increase a little. So let's see what they could be. The first one, what are the difference between a security group and a network ACL in AWS? The response could be, security group act as a virtual firewall for EC2 instance to control inbound and outbound traffic. They are stateful, meaning if you allow an inbound request, the response is automatically allowed regardless of outbound rules. Network ACLs, access control list, operate at the subnet level and control inbound and outbound traffic for the subnet. They are stateless, so both inbound and outbound rules need to be explicitly set. Moving on to the next one. How can you implement high availability for an application in AWS? So there are various ways. Let's see what are the possible ways we can do it. So first one, regions and availability zones. Deploy resources across multiple availability zones within a region to ensure fault tolerance. So AWS would have multiple data centers across the geography and the zones, which is divided into geographical locations. So deploy the resources for an application across availability zones within a region to ensure fault tolerance. So if anything happens to a particular location or a particular data center per se, you would have an instance for the same applications available on the other data center or other zone. So that is one way. Elastic load balancing, ELB, distribute incoming application traffic across multiple targets, such as EC2 instance in different availability zones. There is another way. Auto scaling group, automatically adjust the number of EC2 instance to handle the load, which we have discussed previously also. RDS multi-agent deployments. Use RDS with the multiple agent for automatic failover in case of a database instance failure, which is like a failing over a node from one node to the other node in case anything goes bad with the node 1, which will help in maintaining the high availability of the application. Cross-region replication. Set up cross-region application for services like S3 to enhance disaster recovery capabilities. So you have multiple geographical regions, east, central, west as an example. So if you have hosted the instance in east, set up a replication in a cross region like in center as an example. In case anything happens in a particular geography, you will have the data available on the other geography, and it would help with the disaster recovery. Jumping on to the other one, how do you manage and automate patching for EC2 instances? So AWS system managers System manager, patch manager. Automate the process of patching managed instances with both security related and other type of updates. Maintenance window. Schedule patches to be applied during the predefined maintenance window to minimize disruption. So maintenance window would be preferably the window where the number of users are minimal or there are no users as such, which could be a weekend, Saturday or Sunday, or any time in our business hours, wherein we know that there would not be any users or very minimal users. So we can schedule that window, and the system will patch the servers on that window itself. You don't have to have manual intervention. Automation documents. Use AWS System Manager automation to create documents that automate common tasks, including patching. So by using this, we can automate the patching process with the predefined policies, which kind of patches to be pushed, when it to be pushed, and other stuff. The next question could be, what are Amazon CloudFront and its use cases? Amazon CloudFront, a content delivery network (CDN) service that securely delivers data, video, applications, and APIs to customers globally with low latency and high transfer speed. Use case: improving load time for websites and applications, streaming video content, distributing softwares, and enhancing security for your content by leveraging features like AWS Shield, AWS WAF, Web Application Firewall. The next question: explain the process of setting up a VPN connection between an on-prem network and an AWS VPC. Create a virtual private gateway, attach it to your VPC. Create a customer gateway, provides a public IP address of your on-premises router. Create a VPN connection. Configure it using the virtual private gateway and customer gateway. Download the VPN configuration. Apply it to your on-premises router to establish the connection. Now, we'll move to few of the scenario-based questions. So let's see what they could be. The first one: how would you troubleshoot an EC2 instance that is not responding? So you have a virtual machine and it is not responding. So in a real scenario, if you're working in an AWS administrator, how you would manage that situation, or how you troubleshoot the issue to bring the server back to a healthy state? So the possible ways: check instance status. Use the EC2 console to check the instance status checks. Check the status if it is healthy, unhealthy, if there are any errors, and so on. Review the logs. Access system logs using the EC2 console or CloudWatch logs to see if there are events, there are alerts on the application, or and so on, or there are any event IDs which you can go through it. Network configurations. Ensure the security group and the network ACLs allows the required traffic to flow. SSH access. Verify the key pair and correct user for SSH access. Instance restart. Reboot the instance if necessary and monitor its behavior. Now, the next one: what steps would you take to set up a VPC with public and private subnets? Create a VPC. Define the CIDR block. Create subnets. Create public and private subnet with the VPC. Internet gateway. Attach an internet gateway to the VPC. Route tables. Create route tables and associate them with the subnets. Configure routes in the public subnets route table to direct internet traffic to the internet gateway. Now, the next is NAT gateway. Deploy a NAT gateway in the public subnet and configure the private subnet's route table to route internet bound traffic to the NAT gateway. And then security groups and ACLs. Configure security groups and network ACLs to control inbound and outbound traffic. So by following this, we would be able to set up a VPN with public and private subnets. The next one, how would you implement a backup strategy for RDS database? Automated backups enables automated backups for the RDS instance and set the backup retention period. Manual snapshots is another way. Take manual snapshots periodically or before major changes. Cross-regional replications. This way you can replicate the data to other location. Set up read replicas in a different region for disaster recovery. Backup monitoring. Use CloudWatch to monitor backup processes and receive notification on backup status. So these are the way how we can implement a backup strategy for an RDS database. How do you handle patch management and updates for the AWS infrastructure? EC2 instances. Use AWS Systems Manager Patch Manager to automate patching for EC2 instance, which is the patching of virtual machines. The second is RDS instances, how we can patch the RDS instances or database instances. So enable automatic minor version upgrade for RDS. Elastic Beanstalk. Configure environment settings to apply updates during maintenance windows. Lambda functions. Ensure the runtime is up to date and apply updates as necessary. Question. Your application experiences slow performance. How would you troubleshoot and resolve this issue in AWS? Check CloudWatch metrics. Monitor CPU, memory, disk I/O, and the network I/O metric for your EC2 instance. Analyze application logs. Use CloudWatch logs to check for any application errors or performance bottlenecks. Review auto-scaling policies. Ensure your auto-scaling groups is appropriately configured to handle the load. Inspect load balancer. Check the health of instances behind the ELB and ensures it's distributing traffic correctly. Database performance. Monitor RDS performance metrics such as read-write IOPS and consider scaling up or using read replicas. Network latency. Use VPC flow logs to check for any network issues. The next one under scenarios, best questions category would be, how would you migrate an on-premises database to Amazon RDS with minimal downtime? The steps would involve AWS Database Migration Services, DMS. Use AWS DMS to migrate the database, set up a replication instance, and create source and target endpoints. Schema Conversion Tool, SCT. If the source and the target database are different, use AWS SCT to convert the database schema. Continuous data replication. Start the data replication task and allow it to catch up with every changes made during the migration period. Switchover, which is actually the cutover process. Once application is catch up, switch your application to the new RDS instance during a low traffic period to minimize downtime. So this way, the migration can be achieved. How do you ensure that your S3 buckets are secure? Response. Bucket policies. Define policies to control access to the bucket and its objects. IAM policies. Use AM policies to target least privilege access, bucket access control, implement bucket level and object level permissions, encryption, enable server-side encryption SSE and enforce encryption of data in transit using HTTPS, logging and monitoring. Enable S3 access logging and use CloudTrail for auditing bucket access. Block public access. Ensure public access is blocked unless explicitly required. Question. What is the importance of tagging in AWS? Cost allocation. Track and allocate cost to different projects or departments. Resource management. Organize and manage resources by tagging them according to the environment, dev, test, prod, owner, or purpose. Automation. Use tags to apply automation scripts or policies to specific resources. How do you manage tags? Tag policies. Implement tag policies to enforce consistent tagging across all your resources. AWS resource group. Create and manage resource groups using tags for easy monitoring and management. AWS config rules. Use AWS config rules to ensure resources are tagged correctly and comply with organizational policies. Now we'll move to set of behavioral questions. The first one would be describe a time when you had to resolve a critical issue in your AWS environment. What steps did you take and what was the outcome? So this is a very open-ended question and it would vary from vary for individual to individual. So try to form a response of try to prepare an answer beforehand for any of the issue which you have actually worked on. So this answer will vary based on your personal experience. Provide a detailed account of a specific incident, the steps taken to resolve the issue, and the positive outcome or lessons learned. So break it into when you are preparing for a response. Break it into three sections. First, provide a detailed understanding or explanation of the issue. Then go to explain the steps taken to resolve the issue and the positive outcome of the lessons learned for future, and so that we can prevent similar issues in the past. So suggest prepare if you are appearing for an interview, have this have this response ready or answer ready with you because it's obvious that interviewer would ask a question like this. The next one. How do you stay updated with the latest AWS services and best practices? So it could be done by using or attending AWS trainings and certifications. Regularly takes AWS training courses and pursue certifications. AWS documentations and white papers. Read official AWS documentation and white papers. AWS blogs and forums. Follow AWS blogs, forums, attend AWS events. User groups and meetups. Participates in AWS user groups and meetups to network with peers and learn from their experiences. With this, we have came to the end of this video. Hope this would have been useful. Best of luck for your interview preparation. Thank you.